The moon leaving our planet, the sun swallowing the Earth, and our galaxy colliding with other cosmic giants. The future of the universe is impossible for us to witness, but still, let me show you a tiny glimpse of it. We all think a day is fixed at 24 hours, but what if, over time, that day could stretch to double or even 10 times its length? Right now, Earth's rotation is slowing down. A single day gets longer by about 1 second every 1 to 2,000 years. Doesn't sound like much, right? But time has a habit of stacking. In just 3 million years, we'll gain an extra minute. In 180 million years, days will stretch to 25 hours. And if the Earth still exists 4.5 billion years from now, 1 full day will last 48 hours. The reason behind this slowdown is our constant companion in the sky, the moon. Although the moon looks fixed in the sky, the moon is quietly drifting away from us at about 3.8 centimeters a year. This gradual escape has been going on for billions of years, and it's key to why our days are growing longer. When the moon first formed 4.5 billion years ago, it was much closer, possibly just 20,000 kilometers away compared to today's 380,000 kilometers. Back then, Earth spun fast with days lasting only 5 to 6 hours. If this drifting continues, in roughly 50 billion years, the moon will be so far away that Earth's rotation could actually stop. At that point, the Earth and Moon would be tidally locked, with one side of each always facing each other. A single day on our planet would then stretch to 27 Earth days, or about 655 hours. Of course, there's a catch. Our planet and Moon probably won't last that long. In about 5 billion years from now, the Sun will have used all of its fuel in its core. As a result, our Sun will enter the red giant phase, growing more bright, larger, and cooler on the outside. Mercury and Venus will be swallowed whole. If Earth will meet the same fate is uncertain, but if it survives, it won't be much to celebrate. Just a lifeless dead rock. Meanwhile, moons further out like Titan might actually become habitable. And then, about 2 billion years later, the Sun makes its final move. It blows away its outer layers, forming a glowing planetary nebula lit by a white dwarf that remains the tiny, dense core of what was once our brilliant star. The Milky Way isn't drifting through space alone. It's part of a small gravitational bubble called the local group, a cluster of over 80 galaxies scattered across 10 million light years. Most of them are faint, small dwarfs, barely holding on to the structure. The dominant ones are Andromeda, the Milky Way, and Triangulum. Some galaxies, like the Large Magellanic Cloud, are so close you can see them with the naked eye. They are satellites tethered to us by gravity. But here's where things get weird. While the rest of the universe is expanding, pulling galaxies apart at an accelerating pace, the local group is doing the opposite. It's gravitationally bound, tightening over time. It's essentially collapsing inward. For years, astronomers believe that around 4 billion years from now, the Milky Way and Andromeda were guaranteed to collide. The event would be epic. The galaxies would engage in a cosmic dance, millions of years long, until they would merge into one. That version might still happen, but thanks to new data from the Gaia and Hubble telescopes, plus over 100,000 simulations, there's only a 50-50 chance we'll actually merge with Andromeda in the next 10 billion years. That's not just a plot twist. It's a rewrite of the galaxy's future. The difference is that gravitational nudges from galaxies like Triangulum and the Large Magellanic Cloud may subtly change Andromeda's path, maybe enough to miss us entirely. Still, The long-term fate is clear. Our local group is doomed to unify. Andromeda may loop back, Triangulum may emerge early, and one by one, the smaller galaxies will be pulled in, fading into the growing core. But before all that, we've got a more intense collision coming up. The Large Magellanic Cloud is already falling towards us, fast. In just 2 to 3 billion years, it's expected to slam into the Milky Way, disrupting our disk and triggering star formation, and even possibly kicking our central black hole into overdrive. Eventually, it won't be a group at all. It will be a single, huge elliptical galaxy, ancient and filled with the stars of 100 swallow civilizations, formed by over 80 galaxies, including the Milky Way. A cosmic monument. But here's the question worth asking. Will anyone or anything still be around to see it? Because while galaxies take trillions of years to fade, stars, planets, and life as we know it, they burn out a lot faster. The universe doesn't rush.